Circular motion is a very important topic in physics, so I'd like to go over the key points right now. Let's say we had an object moving in a circle. This is a bird's eye view here, okay? With a certain velocity going around the circle counterclockwise. Now, you can imagine that a bit later, it might be over here as it's going counterclockwise. And you'll notice the velocity is always tangential to the circle. Okay, and let's say our object is going at a constant speed around the circle. Now, it's really important that you understand the difference between speed and velocity. Speed is like 35 meters a second. Velocity is a speed and a direction. So a velocity would be 35 meters per second south, okay? Speed and direction. So we're going to say the speed of this object is the same as it goes around the circle, say 5 meters a second the whole time. Is that object accelerating? Well, it's tempting to say no because, as you should know by now, acceleration is defined as the change in velocity over a change in time. Now, the key point is that it uses velocity in the definition. So remember, velocity is a speed and a direction. So even though this object is going at the same speed, say 5 meters a second around the circle the whole time, its direction is constantly changing. And that counts as an acceleration. And the main thing to know about that is what's called centripetal acceleration is always pointed towards the center of the circle. I'll hang a little C for centripetal. So over here, that centripetal acceleration is pointing towards the center of the circle. Whenever an object goes around a circle, it's always accelerating towards the center. I hope that helps your understanding, and we will see you next time.